Hello! So tonight what I'm going to do is show you how to use one of these cool little SR04 ultrasonic transducers. They're fairly simple to use. They're 4-wire devices. They have a voltage in, a ground, and of course you have a trigger pin and an echo pin. Basically the way these guys work is we send a pulse to the trigger pin, and then it's going to send out a 40 kilohertz pulse, a chain of them actually, out of one of the transducers. And then it's going to listen for the echo on this other pin. And then when it does, it's going to calculate out the distance something is by knowing, for example, the speed of sound in air. Before we actually get going on it, let me show you a little bit of a data sheet here. You can download a variety of different ones. They're actually all a little bit odd because the translation seems a little bit funny. But if we scroll on down, we can see the most important thing that we're looking for is the mathemagic that's going to make it go. Like I said, we're going to need a 10 microsecond trigger that we send to the trigger pin. This is important to note. You can't reproduce that trigger again for at least 50 microseconds. In the code demo I'm going to show you I actually waited 1,000 microseconds or 1 millisecond. And then we're going to listen for the echo. And once we get that echo, we're going to go ahead and be able to calculate the distance in either centimeters or inches by using this simple formula right here, which is the echo pulse width microseconds divided by 58 is going to give us our distance in centimeters, and the echo pulse width in microseconds divided by 148 is going to give us our distance in inches. So if we look at some code here, I'll pull that up, you can see that I have, well, actually before we do the code, let me talk about actually wiring one of these guys up. There's a couple ways to do it. The way I like to do it, I've got a 4-position header up here, although you wouldn't have to have a 4-position header, it could be just 4 individuals. But it is important to note again that the voltage and the ground are opposite sides. So in that case it's the green and the gray wire in this particular bundle. And you can see what I've done is I've taken and pulled them apart down here at the end, and I have the green and the gray on one double, so this is going to be my voltage and ground, so I can plug it in anywhere there's 5 volts. And then of course the two here in the middle are going to be the digital pins, which are going to correspond to the echo and trigger. The reason I split it like this is, for example, right now this robot is set to run at VN, so I'm powering these motors at 7.2 volts, which means that this entire side of the motherboard on the center row of pins is 7.2 volts. So I don't want to plug this on this side, okay, because if I did that I'd be overpowering this device and probably burn it out. It's only set for 5 volts. So I want to run my power from this side. Now these are digital, okay, and what I oftentimes run out of is analog pins. So I usually have extra digital pins. So I want to be able to span across. Okay, so I'm going to go ahead and plug this guy in. I'm just going to use these 2 pins down here. So I've powered it up right now on pins 13 using the 5 volt and the ground. And I'm going to plug this guy into 2 digital pins here, 11 and 12. So now I'm set to actually start to program it. And let's look at some code. Okay, I should check this first. I've set my trigger pin to 12 and my echo pin to 11. My trigger pin is the blue one. Yep, see, looking here, the trigger pin is the blue one, and in fact, if my trigger pin is, so I either have to change this or I have to flip this around because it's important that my trigger pin be 12. I could change it in software, but I'm going to just change my cable. And my echo pin, okay, is 11. So now I've wired it up correctly. So I have got my power and ground on this side of the board, and I'm using digital pins 11 and 12 on this side to actually do the echo and trigger. Alright, I'll set that aside for a second. Let's look at the code. Of course, you just figured out that I've set those variables to 12 and 11, so I know those pins. I need to create a few other variables to play with. I need the echo time, which is the time the pulse is when it listens to the echo, the duration of the pulse. I need to know be able to calculate out the distance in centimeters, the distance in inches, and I'm actually going to be doing this with non-void functions. So I'm going to actually be able to equate it to distance. So I'm going to set my distance as equal to a non-void function looking for centimeters or inches, and I'll show you down here in a second. My trigger pin is going to be an output. I want to send a pulse to it to make it scream out silently in ultrasound. And then my echo pin is going to be an input. I'm listening for the echo, so I have to make sure I get those set right. I have already set, and I should probably, no, I've already set my trigger pin to low, because that's where it's going to always kind of be at the base. I want to be able to keep it low until I send out a pulse, and then it goes up high very, very briefly. And I'm opening up a serial port. My loop, okay, like I said, I've actually set these to non-void functions, so I'm going to set the distance is equal to, in this case, I'm going to call the function echo cm, and then down here I'm going to call the distance is equal to echo inches. And now let's look at those particular functions. Echo cm, okay, I'm actually holding it low for an additional millisecond, 1,000 microseconds. And again, let's keep in mind, I can do it every 50 microseconds, but what the heck? I mean, a millisecond is not going to kill us, so I'm just going to hold it low for certain for 1,000 microseconds, and then I'm going to pulse it for 10 microseconds. And I should show you where I got that information from. This is going to be right here. This is the trigger pulse, a minimum of 10 microseconds. Okay, so I hold it low, I wait, and then I set it high for 10 microseconds, and then I set it low again. So I've sent out the ultrasonic signal. Now I'm listening for the echo, which I'm going to take a pulse in, and I'm listening for a high signal. And in this case, I'm calculating centimeters, so I'm going to go ahead and take the echo time divided by the 58, which of course we got from this formula right here. Okay, and that then returns centimeters back up to here. And I also do the same thing down here. All this is identical. The only difference is I'm dividing it by 148, and I'm returning the inches. So I'm going to load this up and pause it, and I'll see you in a second. Okay, so I've got everything running, and I'm going to use this ruler here to kind of show. I've got it set at approximately 10 centimeters, and this is hard to do. I'm going to hold that basically at the edge of the ruler, right about, well, actually it starts on the inside. And you can see it's pretty darn good. I'm measuring 10.5 centimeters, and I mean, you know, I'm not exactly sure where the sound begins. I'm sure it starts somewhere at the end of this transducer. And if I slide it on down, that's a roughly, you can slide down here roughly to 14. And you can see it's pretty darn good. It's actually very accurate and pretty stable. All right, so the next thing I'm going to do is actually put a clamshell around this and mount it on my robot, and I'll see you in a second. Okay, so to mount this, you're going to need a few different pieces. You need both halves of the ultrasonic clamshell. This is kind of an optional piece here. You may or may not want the extension. I'm going to use it. And then, of course, we've got the bracket that actually mounts it to the chassis. So what you want to do, I've actually noticed I've pulled the plug, so I've got the power off on this guy, is this guy just sits in here like this. Okay, simple enough. And then this just sits on the back like so. All right, and it just gets sandwiched in. And then you need a couple of screws that are long enough and a couple of nuts. And I'll tighten it up after a bit here. But basically, there you go. It's clamshelled in. Now I'm going to actually mount mine I'm going to be looking for robots attacking the side here. Now I could mount it way out here on this side someplace, but I'm actually probably going to mount it back here. It's kind of scanning a little bit in this direction. So I'm going to actually mount this guy, I think, maybe here. And then I'm going to put this lever arm in here. So let me pause this and set this up, and I'll be back with you. There you go. So I've got this guy mounted, and I'm going to have it aiming slightly down, something like that, so that I can see approaching robots as they try to attack me from the left or to the right. Alright, well, there you go. And next what I'll do is I'm going to mount another one on this side, and then I'll do a little code demonstration, so I'll probably see you in the next video here fairly shortly. See you soon.